What are we doing today?
We're flying with Shahar.
We're going to have some fun.
My heart is pumping.
Is it? Are you
Yeah.
excited?
Yeah. All the data professionals should feel really at peace because at its core, AI is just relying on the data underneath. And context engineering is providing data at the right time. That should sound very familiar to anyone in analytics and data. We could just fly over cities like this.
Yeah, that's how we roll.
That's how you roll, Shah. A very simple question you can usually ask yourself is, where do I have my highest leverage? By improving the volume or by improving the efficiency?
So if you started your career all over again today, as a data scientist or as a data engineer, what would you do differently?
Oh, that's a good question.
Hey,
Hey,
how are you doing?
very well.
What are we doing today?
We're flying with Shahar.
We're going to have some fun. So we've just started the helicopter. Let me just talk you through what is happening. So the clutch was basically doing this and getting engaged. Now it's fully engaged. So we can increase the engine RPM a little bit, and we're going to warm up the engine. This is like the old temperature, cylinder head temperature. We want to give the engine a nice warm up because it's the first flight of the day. It's been cold, so we want to let it warm out gently before we, start bashing it around. And we just need these two to get in the green range. We're going to do a couple of tests on the ground, make sure everything is looking fine, and then we can get going.
Right. This is very exciting.
It's amazing, right? And you can actually see that it looks like a disc, right? This
Yeah,
is what I was telling you on the ground earlier, is basically, and I'll show you this in a second, but basically the controls that I have the pedals, they control the tail rotor at the back, and they basically help me, turn the helicopter around this axis. And then you've got the disc, and you can see if I move the cyclic forward, you can actually see it moving. Can you see it?
Oh my God, yes.
Look to the side. Can you see it moving?
Yeah.
So look at my cyclic. I can basically do this. I can move it wherever I want.
Oh.
See my cyclic? Look. I can move it this way, that way, wherever I want.
So cool.
That's
it
insane,
mirrors
right?
exactly the disc, yeah.
Exactly.
Yeah.
So that's controlling the direction. And as I said, like I think of it like a disc that's generating lift. And I can control the direction with this, and I can control the intensity with the collective. So the collective, when I raise the collective, then it's collectively raising all the blades' angle of attack, so it's generating more lift, all blades at the same time. So that's basically how we go up and down. So this is up, down, this is direction, and the pedals help us, keep the nose of the helicopter where we want to go.
Otherwise we would spin out.
Yeah, exactly. So it's Newton's third law, right? Every action has an opposite counter reaction. So the engine is trying to turn the main rotor around, so the main rotor is trying to turn the helicopter around, and this is why we need the guy in the back to counteract this.
Exactly, yeah.
And we have this very long tail section just because we want a big momentum, otherwise we need a lot of power there.
Of course, the further out you go, the more momentum you have.
Exactly. Okay, so engine is sufficiently warming up, so we can increase the engine RPM between 70 and 80, so let's say 75. The second thing I'm going to test on the ground is the needle split. So you see, this is how fast the engine is running, this is how fast the rotor is spinning.
Okay.
And the rotor is supposed to freewheel. This is what Q just said, that if you want to land anywhere, you don't need an engine, you just go down. But it means that the rotor needs to be able to freewheel. So I'll bring it up just closer to 80, and then I'll roll it over. So you see that the engine is going down immediately, but the rotor can maintain its momentum, so that's good. It means that it can move freely.
Really, yeah.
Without
so that also
the engine.
means if the motor cuts out, we actually still have...
Yeah, this thing can go on its own, and then we can basically just do pull out an emergency landing anywhere.
Yeah. That's awesome.
And then, so these guys are going off now.
Okay.
We'll go after them.
Booking out information, Captain. Low Bell, Lima Oscar, Bravo, Echo Lima, heading up to...
Wow.
Let's call Denham. Denham Radio, helicopter Golf Delta Alpha X-ray Alpha, HQ are requesting airfield information and radio check.
Golf Delta Alpha X-ray Alpha, route 35, 24 right hand, QNH 989 hectopascals.
989 and 24 right hand, and we're going to a private landing site near Newbury, 2 people on board, retaining today, captain's name, Meir.
X-ray Alpha, that's all, copy, thank you, and report your lift and departure.
Lifting now, Golf X-ray Alpha. Okay, we can get going. So what I do now is, if you look straight, we're basically raising the collective slowly.
Bravo Alpha,
and you can start feeling maybe that the main rotor is taking our weight, and I'm going to try and feel what the helicopter is trying to do,
Wind 1604.
and basically counteract that. So
Golf,
that's
Tango
it.
Sierra Bravo Yankee, ready to depart and turn.
We're flying.
Golf Bravo Yankee,
Backwards.
thank you. In turn, surface wind is 1608.
Charlie Yankee going round.
Okay.
Charlie Yankee.
This is a very
The
new
heli's in, so you
feeling for me.
we were feeling a little bit threatened by your proximity. Sort of 30 metres would probably do it.
You feeling good?
I'm feeling very good, yeah. We've got 3 grams, 2 fuels, no lights.
Not gonna lie, my heart is pumping.
Is it? Are you
Yeah.
excited?
Yeah. Adrenaline is going.
Now with the pedals,
Golf Bravo Yankee, ready to lift.
you can turn like this, right?
Surface wind is
Wow.
And look around and see who's around me. So I see that base is clear. There's one aircraft taking off right now, so we can go behind them. And see, keeping the helicopter stable in a hover is actually very difficult. Like, see how many tiny control movements I need to make just to keep it in one place.
Yeah, it's
I'm
fascinating.
always moving. And Golf X-Ray Alpha ready for departure behind the 152.
Golf X-ray Alpha, Roger 163 on base, short turning final, surface wind 1808.
Golf X-Ray Alpha rolling.
Okay. All right.
Roger, please turn to the
There we go.
fixed wind.
Holy shit. Okay.
Surface wind 15010.
Wow.
To the fixed wing on final.
Yeah, it feels much more stable in the air.
So it's kind of like bike, right? When you ride your bicycle, if you're at a very slow speed, it's very wobbly, but then if you go faster, it actually gets more stable, and flying is kind of like that. We have a lot of things that stabilize us as we go faster.
Wow, okay.
Okay, so we're gonna follow them on the departure path.
Whew.
How are you feeling?
Adrenaline.
We're feeling good, right?
Yeah. If you feel good, I feel good.
I feel awesome.
We could just fly over cities like this.
Yeah, that's how we roll.
That's how you roll, Shah.
And Golf X-Ray Alpha passing St. Charles 1000, free calling en route.
X-ray Alpha, thanks, see you later on.
See you, thanks. So I feel like we need to do a quick introduction because we kind of got into it without actually talking about who are you. So we've got Enzo today. Do you want to introduce yourself? Who are you? What do you do?
Absolutely. I'm Enzo. I've been in the data space for more than 11 years now. My background originally was econometrics, which a lot has to do with modeling the world. And for modeling the world, you need a lot of computer power and processing power. So I also got into computer science afterwards. Yeah, and then never looked back really after that.
So what do you do today?
I'm the Vice President of Data and AI at Prolific. Prolific is a human data platform that works with academic research institutions, but also a lot of the frontier AI labs on all of their human data needs. So whether that's for research, for pre-training, post-training, evaluation, safety testing, red teaming, alignment work. There's a lot of human data that goes into these processes, and it's a lot of overhead and a lot of operational burden that otherwise would fall onto researchers and these companies. And we're trying to abstract that away. And we're building a lot of automated systems and orchestrations around that. So it's actually really exciting to be part of this as a data professional, because human data is a fascinating type of data to work with. Let me tell
And
you
it's
that.
a good time to do that as well, right?
Oh, for sure.
Good point in time in history.
100%, yeah.
So what is human data?
Human data, I mean, at its core is any data that you capture from humans. Like any type of telemetry or behavioral signals you gather online, what a lot of apps do, you could classify as human data as well. But the specific type of human data that we work with is where we actually try to control who is the human and what type of data they're providing. So in its most basic form, you probably know this from like Amazon MTurk, where you may annotate an image of, like back in the day it was like classify whether it's a cat or a dog or an airplane or a car, right? But these days it's far more involved. You need like industry-leading experts or PhD level knowledge in order to verify what these capable AI systems or ML systems do today, and you need a tremendous amount of data and information in order to make that work. But the really interesting part about it is we're all unique and we're all humans. And so it's really hard to predict of what kind of data actually these systems, what humans actually give in that moment. But the point of human data in AI is to generalize. But how do you generalize from actually a starting point where everybody is unique?
This is so cool. So one of the things I really like about Prolific is that your product is actually data,
Yeah,
right?
that's
So
right.
data is not just a sidekick like it is for a lot of other companies where, if you do data and analytics well, then that's cool. If not, then that's not the end of the world. In your case, it's like, that's literally the product. That's what it is.
That's exactly right, yeah.
Before Prolific, you worked at Meta, right?
That's right, yeah. I was there for a long time. That's where we met Shahar.
Yeah, we did. We actually, I'm gutted because we didn't work very closely together at Meta. We were in the same org, but we're doing different things.
Yeah, it was fascinating. At the time, we were both working on integrity, and in many ways, integrity also has a massive reliance on human data.
Yeah,
And
integrity is a data problem, right?
exactly that, yeah.
Your ability to control, trust and safety issues on the platform start with your ability to define and measure them. If you cannot measure, if you cannot define, then there's nothing you can do about it.
Exactly. And then also, if you look at it that way, right? Meta has platforms that span the entire globe, and what might be okay in one part of the world might not be considered okay or permissible in another part of the world.
Right.
So how do you solve for global representative? It's a really challenging problem, especially if you start modeling in these type of environments. We deal with that also at Prolific because we give data that lends the ability for some of these model builders, and that's these systems. They also serve a global audience. So we very much also care about the representativeness of.
And this is a taxonomy problem, right? Like the ability to have ground definitions of what do things mean. I always remember, like at Meta, one of the problems we're dealing with was nudity, right? Nudity content. And I always thought, okay, the definition of nudity in some countries is very, very different from the definition of nudity in others. Like in some countries, even showing your shoulders could be considered nudity, and in other countries, walking on the street with bikinis is perfectly fine.
That's exactly it. And that's what makes human data so challenging, as opposed to, for example, let's say, commerce data. If you have a web shop and you just capture the clicks of something, like that type of telemetry is super consistent. But with human data, the Unity example, or also like if you ask someone to annotate something, you need to be quite careful of how you phrase the instructions. If you phrase the question, how do they interpret the question? Because it's a human interpreting the phrasing of the question and then applying a potential grading on the back of that. But what happens if humans are misaligned? They interpret the questions differently. What if there's language differences? If there's cultural differences? And then how do you bring global representativeness into that when humans are already in itself quite misaligned? And that makes it fascinating to work with.
Wow. Okay, so what do you think are the biggest challenges in the data industry right now from your perspective, data and AI?
I mean, we're actually in a really exciting space. We have this massively new technology coming. Well, it's actually not that new, but it's becoming extremely viable right now with AI. So it's really shaking up a lot of things, right? All the data professionals should feel really at peace because at its core, AI is just relying on the data underneath. And I know the term that's really emerging is the term context engineering, right? Context engineering is providing data at the right time to a system. That should sound very familiar to anyone in analytics and data. Like our literal job is provide signal from the noise and process data in a way that makes it accessible and provides the right context at the right time to enable decisions.
Look at that.
So
That's one house. I don't know if people can see it, but it's insane how big this place is.
there's some rich people here. So beautiful.
We're so lucky to be doing this,
Genuinely. I really appreciate you taking me along.
I'm so pumped you came up. So do you think as data people, because the idea of managing context and definition and data governance and taxonomy and these ideas and ontologies, these are not new things. Like we've been talking about this for, dozens of years. Like, do you think that it's changing now?
Part of my role is actually, I also support some parts of our AI research. And there's actually two things that I'm coming to terms with, let's put it this way. And I think one of them relates to data, the other one to AI research. And both of them are with this technology of AI becoming so prevalent in everyone's minds, and you have software engineers applying AI and building systems with AI that previously never had any exposure to it. They start wondering about the same concepts that actually have been in place for a very long time. So one example on the AI research side is evaluations. Data scientists know, machine learning engineers have known this for a very long time. So do data engineers. Back in the day, we just called it measurements. These days, we call it AI evaluation. Sure. But there's not much difference in that. There's actually decades worth of research and insights that we can rely on in metrology, and psychometrics, and in other fields that lend itself actually really well for also AI evaluation. But there's this influx of people who are effectively rediscovering what data professionals have known for decades. And I don't think that's too different now when people now think about context engineering. And if you look at Cloud Code skills, for example, right now, these are just markdown files that are being made available at the right time. Like, that's in itself a very simplistic variant. And data professionals have decades worth of experience for these systems that very well transfer. So I find it humorous at times that people who don't have a background in data or machine learning are rediscovering the same concepts just because they're now working with AI.
Yeah, it's becoming cool again, right?
That's what it is.
But do you think the people who are responsible for a lot of the innovation today, they actually don't understand the history and where we came from?
Possibly. I think it's more in the applied AI space, like all the app builders of the world that are, or product engineers that are now using AI or building with AI. They might have less understanding of the history. But it's actually a massive opportunity for data professionals to contribute to that. Actually, at Prolific, our AI and ML engineers are working hand in hand with the data engineers, just because the context engineering part of it is so crucial. An AI engineer is nothing if they can't provide the right context at the right time.
So do you think the role of data engineers is changing now because of AI?
That is a very good question. I would say yes. It depends though. Because a lot of the data engineering challenges of making sure that you have good systems that reliably can capture data, process data, and make data available in the right data models that can be understood, that core of the problem is not going away or changing. But the consumer of the data might be actually shifting away from a stakeholder trying to consume the data to an agent consuming the data. We are, for example, thinking more and more about agent-ready systems and how an agent wants to consume the data can be quite different from maybe the relational type of data that we make available to stakeholders for a data scientist or an analyst or leadership to work with. Might not look the same as if an agent wants to consume it. So it might be...
What's the difference?
Relational data is easy to understood for humans to consume, to be queried with SQL. But an agent, or on the basis of AI, at least generative AI, is reading from vector databases, embeddings, multi-dimensional space. It also means that you can leverage different data structures all of a sudden that might be not relational, like knowledge graphs, for example, or graph-based system. And most likely, like we see they are actually, I'm watching their space quite closely because I find it actually interesting because they're combining the data structures together. They're combining knowledge graphs with relational databases, with or relational structures and embeddings. Depending on what you need, you can consume what you need or look this up.
So if you started your career all over again today, as a data scientist or as a data engineer, you know, what would you do differently?
Oh, that's a good question. I got into this because I found machine learning really fascinating, and I was one of these people that I put my hand up and I admit it. I was one of these people who just wanted to build cool stuff with cool technology. But if I had to start over and I had to give myself a bit of an advice, especially today, is don't just try to use cool technologies for cool technology's sake. Try to solve some actual problem. And like if you actually understand what you're trying to solve for, then the rest just falls in. So I would start at the back of the problem, work backward. You know, data science especially has a very varied perception. In some instances, they're more like ML engineers. In other instances, they're more closer to analytics. Even though I've started on the ML side, I really think the analytics side is extremely powerful, especially in the advent of AI. And I would probably argue that the future of a data scientist is in analytics and leveraging the power of these new data structures that we have and the AI systems, surfacing the right information at the right time to make decisions and finding patterns across systems is always going to be a challenge.
But a lot of people, they kind of skip that step, right? They try to go to the cool stuff and they do things because people ask them to do things. They don't actually know what is the problem they solve or why they're doing it. So why do you think it happens?
I get it. I've been there. It's fun to talk about these things, right? It's fun to dive deep because it's technical, it's tangible. But it only carries you so far, you know? Some time ago, we spoke about like specialists are ultimately winning out. But when we go through university, for example, or when you try to master a craft, then you look at it from a very technical angle. And technical skills are important, don't get me wrong. But I think, especially in the data profession, a lot of people don't learn non-technical skills. What does it mean to influence? What does it mean to dissect a problem? What does it mean to focus your own resource, your own time on the most important problems? Finding problems that are worth solving and not just solve. No one is teaching you that. You have to figure that out. And that's often the stuff that actually catapults you into the more senior ranks. It's not your technical ability so much. It's becoming more and more table stakes, if you're honest, and it's the other stuff that sets you apart.
So how do you find problems that are worth solving?
I go and ask. I literally go to leadership. I do this in every job I have. First thing I do is I go to senior leadership and I ask them, what's top of your mind? What is the stuff that keeps bubbling up in your head? And I try to find the patterns in that. I call this my own calibration process. Every company is different, every problem is different, so you need to calibrate yourself to that. And in data, we're pattern matchers and we're problem solvers. So first we need to define and identify them. But it's just conversations.
A lot of people are struggling to get these conversations in first place, right?
That's true.
Why is that? Because you're very comfortable going to the CEO of Prolific and talking to them, but a lot of people are not.
That's true, yeah. I mean, especially if you're new to a company, right? You haven't built that trust yet. But there's always availability, like to just reach out for a coffee chat. Like if you just come with a curious mind, I usually have found that most doors are open, even if it's just for a quick chat. But the most important thing is, at the end of every chat, is that you connect to the next time you want to connect again. You ask them questions of like, okay, I'll keep you in the loop, and how do I keep you in the loop? Or who else should I talk to? Or like, can you give me a resource of where I can learn more? That you're not getting stuck in your sort of first order connection in your graph, but you actually expand your graph and you learn more. So you don't end up in a dead end.
I love it, and I talked about it in my career Unblocking mini course. I had a section about working with leadership, and one of the things is like go talk to your leaders, find the problem, but actually solve it for them, follow up, follow through, show them that by talking to you they're able to achieve their goals better, and that's really helping build trust.
Yeah, that trust that compounds quickly, right? If you show it once, they're gonna come again. I know most places they have these performance reviews and whatnot, and it's all super formulaic. But at the end of the day, I know we all try not to admit it, but at the end of the day, this trust is built by a personal relation.
100%. So I'm just gonna talk you through the place we're landing because we're just about to land, so we need to find the place.
All
And
right.
it's basically just a pub. So this is the M4 that goes all the way to Bristol and Bath, and goes to the west. And we're gonna start descending now, and the pub is just on that side. So we'll just fly over it slowly, identify it, make sure we see our landing spot, that it's clear that there are no any special threats or anything like that. No people, no animals, no like trees, cables, anything that can interfere with our landing. I've been there many times before, so I know the place. But you always go around and make sure that it's clear before you actually come in, and then we'll just do a small circuit around it. We'll descend and come in for landing. It's not an airport. It's not a controlled place. We don't have to talk to anyone. We just have to go and do it. You see the pub just over there, and there's a triangular shaped small green field.
Amazing.
So that's where we're going. Just need to make sure we land in the right one, but I think we're going to be fine.
Okay.
It looks clear to me, no people, no obstacles, no nothing. So we've identified the space, we're positive. We're going to come back in, we're going to give ourselves some space for the descent to make it gentle and nice. Yeah, we'll be on the ground in like 2 minutes.
All right.
That's crazy, right?
Absolutely doesn't.
It's also very interesting because when we're flying over it, you probably thought that it's a very tiny spot, right?
Yes, very much so. It
Very difficult to judge, you know, how big things are from the air.
I mean, everything looks tiny from up here.
Yeah, so what you need to do is you need to look at a car, for example. With our long tail, we're probably the length of 2 cars, right? So
Yeah.
ask yourself, can I fit 2 cars in that spot? That gives you the perspective.
Way bigger than I thought.
Right?
That was very smooth.
Thank you.
It's almost like you have done that.
It's not my first time. So what we're doing right now is the engine just worked very hard, so we're giving it a couple of seconds just to cool down, and then we're gonna disengage the clutch, so, you know, disconnect the big rotor from the engine, shut down the engine, clear the helicopter. So that's what we're doing now. We can just do this. So we have a rotor brake because the rotor has a lot of inertia, and we need to stop it, otherwise we'll be sitting here forever. That's alright. Okay, so the clutch light's out. The engine is warmer now than it was before. So I'm gonna keep it below 70 until this one gets in the green.
What temperature is that one? The fuel temperature?
That's the cylinder head temperature,
Ah, okay.
and that's the oil temperature.
Uh,
Should we get going?
let's do it.
Okay.
Let's do it.
This is a more vertical takeoff.
This doesn't get old, huh?
Never.
The perspective from up here is completely changed. It's not even the same as from an airplane. England is very beautiful like this.
It's a beautiful country, and people don't realize that.
No, you don't realize it like this from the ground.
So Enzo, I was wondering, you know, we just talked about finding impact and solving real world business problems and all of that with data. Do you have any like examples that you've seen of people using data to solve like really interesting business problems? And how did they go about it?
Specific examples, we can maybe find one or two. Something that really, for me, stands out. Like one of the most impactful things where I see data, when applied correctly, has tons of impact all the time. And this is pretty transferable into pretty much any company, is a lot of what analysts and data scientists are doing with the data that they have. And I've seen this applied wrongly when, for example, a data scientist is part of a team and they're part of their daily stand-ups and they have tickets to work through and all of that, and they're sort of effectively embedded in the current team and the current sprint. And they're thinking very locally, very tactically. That's really not leveraging the impact of what data can do really well. Because the team is then constantly faced about, okay, what about the next sprint and the sprint after? What's the overarching strategy? And they need to make space for that. And then they're going to ask questions. And when nobody's really thinking ahead of that and thinking through scenarios or actually identifying which pathway to go, then the team is going to end up in a place where they're all just brainstorming, throwing ideas on the wall, and then most likely dot vote and stick with the one that most people democratically voted for. Would you argue that's the most impactful thing a team can do?
Not necessarily, no.
Yeah, in some instances it might work, right? If you're starting out as a small startup and you just have a bunch of engineers and you want to try out a bunch of stuff, that makes sense. And for features and incremental product changes, this does make still sense. But like where it gets really impactful is when an analyst or a data scientist actually can create the space to think ahead, and together maybe with a PM and the EM get together and identify like, okay, what are the different pathways the team can take? Where is the biggest bang for your buck, if you will? And then ideally can model something or create a predictive model, or can actually leverage data to create different trade-offs, so the team has more actual grounding in which direction to take. And that will determine future sprints. That will determine what the team is actually working on. And that's grounded in the business impact. And for that, you have to also understand what the company is optimizing for. And this is where analytics is pretty much driving it all. Right? The CEO is not just going to go, oh, I feel like this today, or we're optimizing this because I said so. It's most likely that you're optimizing for a set of KPIs. And it's crucial that you break down these KPIs into the specific product team or whatever team you're working on. So you're decomposing that. And ideally, the strategy is rooted in that. So if, for example, top-line revenue it's usually a form of volume to efficiency. A very simple question you can usually ask yourself is, where do I have my highest leverage? By improving the volume or by improving the efficiency? And that is often a very easy example of where analytics has immediate impact. Because if you ask a bunch of people, put them in a room and ask them, where's the biggest impact? They're going to give you lots of different answers. But you can actually look at it. You can even very easily extrapolate out of like, okay, what will be the impact be on our bottom line if we doubled our volume, or if we have doubled our conversion rate, or halved our other efficiency metrics? And then you will see where the leverage is.
Yeah, and I think this is a super important point, and it's I think that's probably what you're referring to. I call it decision frameworks. Like, how do we know what is impactful, and how do we make product decisions? And in a lot of cases, these decisions are just random or disjointed or whatever, and it's basically people following gut feelings or following things that work for them. But creating a framework for the team, saying, okay, in this product there are 4 metrics we care about. 2 of them are completely out of our control. 1 of them we can control, but it's very slow to respond and not the most impactful. And this one is like the one that we can control, and it's the most responsive one, it's the most impactful one. And therefore we can forget about all the rest and just focus 100% on of our work and effort on just this one single metric and trying to optimize that, right?
That's exactly it, yeah.
And I've seen a lot of cases where, I go to a team and I'm like, okay, show me your top line dashboard. And they show me a dashboard with 50 metrics. And I'm like, okay, cool. So this metric, what do you do if it moves up or down? They're like, oh, we don't know. I'm like, okay, so why is it important that it's here? And they're like, oh, we like to track it and know what's happening in it. And then I ask, okay, but do you have control? Like, can you influence this metric? And they say, yeah, we've tried, it doesn't work. And I'm like, okay, so this is a distraction, right? And I think the best teams I've seen, like literally in my entire career, are not the ones that have 50 metrics, but the ones that have 2 or maybe 3, and they know exactly what to do, and they understand the dynamics between them and the relationships.
That's it.
And they just know, okay, we're going to increase this one, and that's it. And then the rest will just happen organically, and these are things that we can control anyway. So
that's it. And it's actually not that difficult to stand these up, right? So any really good dashboard should have your top line metric, but then decomposing all of the factors that go into the top line metric. So for example, overall, to use this previous example, revenue is decomposing into units plus what you charge per unit. So you can go further and further and like, okay, what can you decompose units by, or users, or whatever you're using in your company. And you can start decomposing each metric into multiple components and their relationship with each other. And then what I usually like to do is like I try to classify, is this an input metric? Is it something we can control? Or is it an outcome metric? Something that has happened as a result of an input. So it tells you where your leverage factors are. And then oftentimes do something very simple of like, look at all of this and then take every single input component and just increase it by 1% and see what difference it makes. So the derivative on your ultimate goal, the top line, that tells you where you have your highest leverage.
Yeah, that's a great point. And I think that the example you've given, right? Units time cost per metric. So you can increase the number of units you sell, or you can increase the cost, but increasing the cost has an effect, like it affects the number of units you're going to sell, because if you double the cost, then people will buy less units.
That's right.
Right? So it's not that it's not one of the levers that you have, it is, but you also need to understand the relationships, and you also need to know, is that really something that I can pursue? And
Yeah,
it's probably more complicated than that because there's cost and there's margin, right? So maybe I
indeed.
cannot control the cost, but I can increase the margin, and therefore I'm still making more money just by selling the same number of units for the same price. And understanding the dynamics of business. And it's interesting that a lot of data professionals, when they, if you look at online trainings and boot camps and courses and all of that, what do they teach you? They teach you Python, they teach you SQL, they teach you, I don't know, scikit-learn and whatever. But nobody is teaching you business acumen, understanding businesses, understanding metrics, setting goals, setting incentives for product teams, building and looking at dashboards, not in the sense of like drag and drop here a bunch of widgets, but in the sense of how to build an effective dashboard that drives real actions and outcomes.
Yeah, and that's it. But you know what I find interesting? Like I have come across a fair bunch of people in my career, and there is definitely sometimes, especially the more technical roles, I have a feeling that there is a prevalent sentiment of being above business acumen. That it's, no, I'm only a machine learning engineer or I'm a data engineer. I don't need to know about business. And I think it's a really short-sighted way of framing things, because if to give the example of the machine learning engineer, what is a goal metric or top-line metric, and then looking at all of the things that influence the top-line metric and maybe some of the constraints that you're trying to avoid. That is a machine learning problem as well, whether you define that for a system that does this algorithmically, or whether you're defining that for an organization that does this collaboratively. It's actually very related concepts. So I don't fully agree with people who think they're above business acumen. No, if you look at, like, organizations are ultimately systems, and I think any good data scientist or machine learning engineer will immediately recognize that if you're training a supervised system, for example, and given an objective function to hill climb against with some constraints, that's not too dissimilar of what you're trying to do in a company. Like, you're giving it a bunch of top-line metrics, a bunch of constraints, and you're decomposing it into different teams. And these teams, they have to ultimately work on maybe sub-objectives that ladder up to the ultimate objective with a bunch of constraints. And that's really not too dissimilar. The system that we're working here is, yes, sure, it's humans, not numbers, but data can really bring what can be a very subjective realm, where there is a lot of, like, interpersonal relationships and influence and career objectives and all of the squishy stuff that we deal with every day. Data can really help bring it into objective space, so people have something as a shared language to reason about, as an organizational hill climbing mechanism.
Yeah, that's a really good way of thinking about it, actually. It's interesting. You see that there is
Ah,
a layer of mist, but then you see that if you look up, it's completely clear,
true, yeah.
right?
It's so interesting. You can really see it. It's like two different worlds. It
Yeah,
explains why everything feels so gray on the bottom. There's some crazy mansions below us.
yeah. Welcome to the English countryside. This is the Thames River.
Oh, no way. Serious?
Yeah. So it's coming all the way from central London. If we had a clear day, you would actually be able to see London from here, like the London skyline.
That's fascinating. The Thames gets really large in London. Here it's tiny. What do you think, Shahar? Should data professionals be leaning into or be afraid of AI? Should they be excited or afraid?
First of all, I don't think it matters if they're excited or not because it's happening. So they have to be on board. The question I ask is, do you know anyone who doesn't use a personal computer today to do their job?
No, no chance.
Do you know anyone working in tech that doesn't have a mobile phone?
Also, no.
I mean, 20 years ago, people would not have phones, right? The way they do today, definitely not smartphones. 60, 70 years ago, not everybody had a personal computer. I think the world is changing, right? And technology is changing, it's evolving. And in some cases, it's disruptive, but also, like, every change creates opportunities. And I think that the people who survive are the people that will adapt to the new reality. Now, people who are, just starting their journey right now, for them AI is going to be given, right? Just like when
Yes.
I was born, computers were already kind of given. I had my first computer at a fairly young age, and I've never been in a world where using a personal computer hasn't been part of the day-to-day job. It's never been my reality. But the people who were there and needed to go through that transition I'm sure for them it was more painful. At the same time, the people who adapted most quickly were the ones who benefited from that and got to shape it and be part of the new reality. So I think of AI as an amazing tool that you have in your toolbox. You need to learn how to use it. You need to use it to your own benefit. And I think in a few years, some of the things we do will not be necessary anymore, right? Also, things become more high level is a good thing in my mind. Like in the past, if you wanted to make the computer do what you want, you needed to program in assembly. So you needed to think about registers and memory and interruptions and making calls directly to the CPU and shit like that. And now these days you have languages like Python that are much more declarative, and you say what you want that will happen, and it's much higher level, but you move a lot faster, you're much more productive, you get a lot more done. I would argue that's generally a good thing.
I agree. And we might even get another abstraction level above that.
It looks like it's happening, right? So you just say what is the outcome that you want and not how you want it, and for many things it's going to be fine. So this is Amersham. Let's call Denham. Denham radio, hello again, Golf Delta Alpha X-ray Alpha over Amersham for rejoin.
Delta Alpha X-ray Alpha, hello again, 24 right hand, QNH 987 hectopascals, and report Maple Cross.
24 right hand, 187, report Maple Cross, Golf X-ray Alpha. I don't think we have a choice. I think, we have to learn and adapt.
Yeah.
Because that is the reality now.
But also, see if this resonates. But if you look at it now, like, probably everybody uses AI now in their coding workflows in their day-to-day to some degree. And probably if you start using it more and more, you realize of how you need to instruct these things. And that usually follows the same framework of you give it some objective, and you give it some constraints, and some way of how you expect the output to be. And especially if you speak about something verifiable, like code, for example, you give it a test. And if it passes the test, or you give it a goal, something that it can verify against. So these systems become more autonomous. But as we said before, that framework is the exact framework that people in data have been using forever. There's a goal and there's a bunch of constraints. So in many ways, this language is already ingrained in your way of working. It's just the tools are changing around you.
I agree, and I think data professionals right now have the biggest opportunity of their lifetime because there's so much uncertainty and lack of clarity in the world right now, and it's not just impacting us, it's impacting our executives, it's impacting everybody. People just don't know what to do, and data is one of the tools you can use to generate clarity. And I think data professionals will not just sit on the fence and wait for things to happen, but will actually take ownership of the situations, are going to be the biggest winners of this whole transformation.
Oh yeah.
So this is the M25.
There you go.
Yeah, this is Maple Cross. We actually just drove by it, and it's one of the entry points to Denham. And Golf X-ray Alpha passing Maple Cross 1000.
Golf X-ray Alpha, no circuit.
X-ray Alpha. Golf X-ray Alpha, turn final side grass.
Golf X-ray Alpha, Rogers, one rotor on the grass north side, at the midpoint, and the surface wind 1407 knots.
X-ray Alpha visual. X-ray Alpha is waxing back to HQ.
X-ray Alpha.
You have to constantly be conscious of what the wind is doing to you in a helicopter.
That's why you have these.
Yeah, that's part of it, but right now the wind is on my tail, and we're kind of like a weather vane, right? It's trying to turn us around.
Ah.
So I'm constantly fighting the wind with my pedals, trying to keep us straight. And also it's, I told you that it's pushing basically bad, turbulent air back into you, so you're not flying in clean air.
Nice one.
Thank you.
That was very smooth.
Thank you so much, yeah. The other thing is when you get closer to the ground, also these vortices, they get disrupted, so you're actually much more effective. So there's a lot of transitions going on, and you move from turbulent air to smooth air, and from being close to the ground to being far from the ground. And there's a lot of things going on all the time that you constantly have to adapt to.
It feels like it.
It's a lot of fun.
I can imagine. I had a lot of adrenaline when we took off. I feel super relaxed at this point. So great job, you.